Unit 4B, Lesson 2. In this lesson, we're going to continue what we started with in Lesson 1 when finding z values using the table. Now we're going to use that value to actually find a margin of error with data given from a poll. When going through the next couple examples, make sure you have your table of z values handy so you can quickly refer to that. Now to the first example. In a poll given to likely voters in an upcoming election, the results showed that voters favored candidate A with 60% of the votes. Calculate the margin of error knowing that 2,000 people participated in the poll and there is a confidence level of 95%. Off to the right, you can recall the formula we used to calculate the margin of error. That's equal to our z value times the square root of p times 1 minus p divided by n. In this problem, we know our value of n is 2,000. Our value of p is 0.60. We need to find our value of z. And we're going to use what we talked about in the previous lesson with the confidence level. If we know our confidence level is 95%, that means 0.95 is going to be equal to 1 minus alpha. If we would go through to solve to get alpha by itself, that simplifies down to 0.05. which means alpha over 2 is going to be equal to 0.025. Just like we talked about when relating to the bell-shaped curve, we're looking for the area to the left of that point. So we would take 1 minus 0.025, which leaves us with 0.975. So now if you go to your table to look for that value, 0.975 is going to be right here in this region. So to find our z value, it's 1.9 plus 0.06. Thus the z value is 1.96. Now that we have all of our needed values, we just have to plug them into the formula and simplify to get the margin of error. Plugging in those values, you get the margin of error equals 1.96 times the square root of 0.60 times 1 minus 0.60 divided by 2,000. So the margin of error is approximately 1.96 times 0.010954, which simplifies down to approximately 0.02, which is 2%. So if we had a poll with 60% voting in favor of candidate A, 2,000 people participated, we want a 95% confidence level. We had to find that value of z, plug it into the formula, and we get a margin of error of 2%. Now to the second example. A poll is taken on the president's approval rating 1 year after his inauguration. The poll indicates the president has an overall approval rating of 47%. Calculate the margin of error knowing that 5,000 people participated in the poll and there's a confidence level of 90%. In this problem, we know the value of n is 5,000, p is 0.47. We need to find the value of z using the confidence level. So 0.90 is equal to 1 minus alpha. If we would solve to get alpha by itself, we know it is equal to 0.10. Now if we divide that by 2, alpha over 2 is equal to 0.05. So now when trying to find the area to the left of this point, we take 1 minus 0.05, which leaves us with 0.95. So this is a value we're looking for on our table of values. So now looking at our table, we have to find 0.95, which actually lies between these two values. So we're going to have to take the average up top. So the value of z is equal to 1.6 plus, we have to take the average of 0.04 plus 0.05 and divide that by 2, which would leave us with 0.045. Combining those together, we get 1.645 as our value of z. Now that we know all of our quantities, We just have to plug them into our formula and simplify to find the margin of error. Plugging those values in, we get the margin of error equal to 1.645 times the square root of 0.47 times 1 minus 0.47 divided by 5,000. So the margin of error is approximately 1.645 times 0.00706, which simplifies to 0.012 or 1.2%. So 1 year after the president's inauguration, he has an approval rating of 47%. That's based on a survey given to 5,000 people. Knowing the confidence level is 90%, we found the Z value, plugged that information in to find the margin of error, which was 1.2%.